Section 2 of this chapter now goes to solids. So, properties of solids. Solids have both a definite volume and a definite shape. There is no container needed to hold their shape, and then their volume never changes either. And this has to do with how close the particles are together. They have a very high density because the particles are close together that make up solids. They do not freely move or flow, they're basically vibrating in place. And therefore, very strong attractive forces hold them in place, which is why their shape and volume does not change. Solids are definitely completely incompressible. You could not take a stapler and put pressure on it and force those particles any closer together. They are lined up very strategically and very close together. They are touching, so you cannot compress them at all. And although we can't say there is no diffusion between solids, we say it's pretty much non-existent. So under certain conditions, with some temperature added, depending on the solid, you may get a slight diffusion between the two, but it's definitely not common, and you have to do some manipulation to even get that to happen. It does not happen naturally. So types of solids, the first is called crystalline solids, and these consist of crystals, so either a single or multiple crystals fused together. The definition of a crystal is a substance in which particles are arranged in a very orderly, geometric, and repetitive pattern. Most of our solids do fall under the crystalline category. Examples include ice, diamonds, salts, and gemstones. So if you looked at these under a microscope, you would see something like this picture here, a very orderly arrangement of the molecules. The other main type of solid is called amorphous solids, and the name kind of gives it away. Amorphous is Greek for without shape. It can morph, if you will. So these solids do not have a regular geometric repetitive pattern. So they can be morphed more easily into random structures. Usually amorphous solids have no specific melting point. They're more soft rather than meltable. So they kind of just soften instead of a traditional solid, which would immediately melt into a liquid. So examples are most commonly glass, which is hard to think about, but glass is quite soft. If you heat glass, you can manipulate it very easily. Plastic, rubber, and wax are the main examples of that. And that's it. So section 2 was properties of solids and the two main types, crystalline and amorphous.